Hello, and welcome back to Summer Work Help for Calculus 1. In this video, we're going to be taking a look at question number 5. So question number 5 says, briefly describe how the following symbols are commonly used in mathematics. So for 5a, we have a symbol here that looks like a triangle. And it's kind of subtle, but it's a little bit thicker on the right than it is on the left. But if you don't see that, that's okay. So this symbol, it is a Greek letter. All right. So if you get on a plane and go to Greece, you'll see this all over the place. It's also commonly used in Greek life in colleges, fraternities, and sororities. This is a Greek letter. And it is a capital delta. All right. So this symbol is delta. Lowercase delta looks kind of like that. But we're talking here about capital delta. And in mathematics, and certainly in this class, this is going to represent a change in some quantity. All right, so when you see delta, when you see this triangle, you should think to yourself change. So, for example, we've looked at slope. We looked at slope in question number 4, and we actually used this equation, y2 minus y1 over x2 minus x1. Well, that's the numerator saying, well, how far apart are your y's, right? So you start at y1, you end at y2, and what's the distance between them? So that's the change in y. So another way to express the same concept is to say, let me do that again, is to say the change in y, and then likewise the change in x. I'm not drawing triangles very well today. There. So both of those are basically saying the same thing, that your numerator is how much did your y value change, and your denominator is saying how much did your x value change. So we want to make sure that we're comfortable with the delta symbol and terminology. All right, B. So B is again a Greek letter, and this time it's a lowercase letter, and it's a lowercase theta. All right, so it's lowercase theta, and this is commonly used, and certainly in this class, I think this is going to be the only context in which we ever use this symbol. It's commonly used for angle measurement. So it's kind of like how we treat x, right? X is just, our input into some function typically. But when we're talking specifically about angles, you can use x, and in some contexts we will use x to represent angles. But it is more likely, and certainly, when you see the symbol, it is almost certainly going to be used to represent an angle. So notice that this could either be in degrees or radians, and we want to be comfortable with both. So an example of where you might see something like this would come up in perhaps trigonometry, where you would see something like the cosine of theta, right? And the trig functions are of an angle, right? So sine, cosine, tangent, cotangent, secant, cosecant, they're all of some angle. So this would be the cosine of, say, 30 degrees, or cosine of a radian measurement. And we're going to see something about that in just a second. So again, this is a Greek letter, theta. It's commonly used for angle measurement, and that measurement could either be in degrees or radians. All right, C. C is a symbol that hopefully you have seen before. Hopefully this is not the first time you've seen this. and it is another Greek letter, and it is a lowercase pi, spelled P-I. And theoretically, I guess you could use this symbol to mean other things, but that would probably not be a good idea, right? This is pretty firmly entrenched as meaning like one very specific thing. So this is a constant. And pi is approximately 3.14. And if you want to give an even better approximation, 3.1416. Sometimes that value is used in certain like engineering contexts and things like that. So either 3.14, 3.1416, and this, you don't necessarily need to know this next part, but I do think that it kind of helps sort of ground the discussion when you're talking about things involving pi. There are many different ways of describing what pi is, but probably on its most basic level, pi is the ratio of a circle's circumference, and I might spell circumference wrong, but that's okay, to its diameter. So what that means is pi is, notice it's equals, not approximately, but it is equal to a circle's circumference divided by its diameter. And again, this is a constant, right? This ratio, circumference over diameter, and circumference is the distance around a circle, and the diameter is a chord that goes through the center. This is always the same number, and it doesn't matter how big or small the circle is. You will always get the same ratio of approximately 3.1416. And there are many other contexts in which you use pi that seemingly have nothing to do with circles. But we're definitely going to see this symbol in this class. It comes up in trigonometry all the time. And then I will also just briefly show you that pi is also pre-programmed. If you're using the TI-84 calculator, it's also pre-programmed. It's right, I don't know if you can see my cursor, but it's right above the exponent key in blue, right? So it's on the right-hand side. It's in blue above the exponent key. So if you ever want to get pi, you could press second and then the exponent key, and there's your pi. And notice that when I press enter, the value of a pretty good approximation for pi is built into the calculator. Now this is not exact, right? Pi, as I think most people know, the digits go on forever. There is no pattern, right? But this is a pretty good approximation for pi. So if you ever have to do a calculation involving pi on the calculator, I would encourage you, don't use 3.14, but use an even better approximation, which is kind of pre-programmed right there. So that is pi, which again, hopefully this is not the first time you're seeing this. But yeah, we're going to be using that in this class. D. Well, D is the only thing on here in question 5 that is not a Greek letter. We saw delta, we saw theta, we saw pi. This is just an English letter, the lowercase letter E that you guys learned, back in kindergarten or whenever it was. This is called Euler's number. And it would be nice to know the name. If you don't remember the name, it's not a huge deal, but this is called Euler's number. And again, you pronounce that Euler, not Euler. All right. So this is Euler's number. Like pi, this is also a constant. And E is approximately 2.718. All right. And again, kind of like pi, there are several different sort of seemingly different but ultimately connected ways of sort of getting E or understanding what E is. One of the sort of the interpretations of E involves something called a limit that you're going to learn about in this class. So I'm not going to use that definition of E because we don't yet know what a limit is. But when you may have seen this in a previous class is when you were looking at logarithms. So even if you don't really recall like what a logarithm is or how they work or how they're related to things, if you've heard of logarithms before, that's a start, right? If you've heard the word logarithm, and we are going to be using logarithms in this class. But this is what's called the natural logarithm. So logs have a base. We'll just say log of x. Logs have a base, and if your base is e, like this, so this is the log of x base e, or log base e of x. Well, that has kind of a special notation where it's just the natural log of x, so ln of x, right? So chances are you're actually not going to see anything ever written like this, right? You're not going to see log with a base of e, because if your base is e, that's called the natural logarithm of x. And E has a lot of kind of interesting mathematical properties that we're going to see later on. And again, there's another way of kind of deriving E here that involves limits that we'll see in a little bit. But for now, suffice to say, you just need to remember that E, it'd be nice if you remember it's called Euler's number. It's a constant. It's approximately 2.718. Also, like pi, it is also pre-programmed into your calculator. So E is actually right below pi, so it's above the division key, and it's right there, lowercase e. So if I press second divide, and e pops up, and again, notice you got a pretty good approximation here, 2.718, et cetera, et cetera, et cetera, et cetera. So if you ever have to use e, it's right there. And then also, you end up seeing e being raised to an exponent very commonly. So also notice that, well, first of all, over here on the left, you have the natural log button, and then above that, you have e to the x. So if you're ever going to be raising e to a power, which again happens somewhat frequently, you can kind of save yourself a step by doing second natural log, and then it automatically brings up, e, right? E what? Is it e squared? All right, great. There's e squared, right? So those are the two different contexts in which you can bring up e on your calculator. And so that is question number 5. And again, question number 5 is kind of intentionally a little bit vague. So if you have different answers here, or if you're looking for like what is the correct answer, there's other things that you can write here for all 4 of these simples. There's more that we could say, but sort of this is how I would answer this question, and it does touch upon some of the information that you're going to need in this class. So question number 5.